Hey guys, and welcome to this video on integer exponents. So without further ado, let's get the show on the road. Alright, before we get the show on the road, I want to take a second to do some practice problems, reviewing some of the skills we learned earlier in the year about exponents. So why don't you pause the video and please evaluate these 8 exponential expressions. Alright, so I hope that went well for you. And just a quick review for some terminology, the number that we're multiplying by itself, that's called the base. The number that tells us how many times to multiply the base by itself is called the power or the exponent, and what we end up with is typically called the product, but sometimes also called the power. So in this example, 4 is the base, 3 is the exponent or power, and 64 is the product, or again, the power. Alright, now that we have those skills under our belt, we're going to discuss what happens when we raise numbers to the first power, to the 0 power, or to a negative power. And we're going to do a little exploration using the bases 2, positive 2/3, and negative 1/3. So what I'd like you to do now is could you please pause the video and please fill out these tables for only the exponents 2 through 5. So you're kind of filling out the bottom of each of these tables. Of course, where it says product is where you're going to put the product. And in the work section, please actually show your work. Please actually multiply the base out as many times as the exponent says to do so. And as you're making your way through, please see if you notice any patterns and see if you might be able to extrapolate those patterns to then figure out what these bases raised to the first power, 0 power, or negative power could be. Alright, now that we got this work done, it's time to see if we notice any patterns. And one pattern that I notice is, for example, looking at the 2 table, every time our exponent increases by 1, of course it's no surprise that we keep on multiplying by an additional 2, so the product gets multiplied by 2. And there's no reason to think that that pattern would only happen for positive exponents, meaning that pattern must have been happening this whole table, even though we haven't filled it out. And of course, for the 2/3 table, every time our exponent went up by 1, we were multiplying by another 2/3, so our product got multiplied by 2/3. And of course, there's no reason to believe that this hadn't been happening the whole table. And last but not least, for the negative 1/3 table, of course, every time we increased our exponent by 1, we were multiplying by negative 1/3 one more time. So our product kept getting multiplied by negative 1/3. And again, there's no reason to believe why this hadn't been happening the entire table. Alright, so now it's time to kind of use this pattern and work backwards to figure out what happens when we raise these bases to the first power, 0 power, or a negative power. So now let's think about what happens when we go up the tables. So if we look at the 2 tables, now we're going to go backwards. As we go up the table, as our power gets smaller and smaller and goes to the negatives, our product keeps on getting divided by 2, divided by 2, divided by 2. And even better than saying that it's divided by 2 is we'll say that it gets multiplied by a half. So as we go up this table, every time the power decreases by 1, we're multiplying the product by a half. And now that we're equipped with this information, it should be no problem for us to find all these products for when we raise to the first power or the 0 power, etc., etc. So let's find them. So of course, 2 to the first power, well, all we need to do is multiply 4 by a half. That's going to give us 2. 2 to the first power is just 2. What about 2 to the 0 power? Well, all we need to do is multiply 2 by a half, and we get 1. So 2 to the 0 power is just 1. Very interesting. All right, now we're going to make our way to the negative powers. 2 to the negative first power, all we need to do is multiply 1 by a half, and we get 1/2. 2 to the negative second power, we multiply a half by a half, and we get 1/4. 2 to the negative third power, we multiply a fourth by a half. We get an eighth. And last but not least, 2 to the negative fourth power, all we need to do is multiply 1/8 by a half, and we end up with 1/16. Very interesting indeed. All right, let's find out what this pattern looks like for the other two tables, and then I'm going to have you fill them in, and then let's see if we can make any generalizations. Of course, for the 2/3 table, as we move up the table, as the powers get smaller and smaller and into the negatives, the products keep getting divided by 2/3. Why? Because we're multiplying by 2/3 one fewer time as we go up the table. But even better than saying divided by 2/3, that's the same as saying multiplying by 3/2. So as we go up the table, every time our exponent decreases by 1, our product gets multiplied by 3/2. And last but not least, as we look at our negative 1/3 table, as we make our way up the table, as the powers get smaller and smaller and into the negatives, the product keeps getting divided by negative 1/3. Or even better than that, dividing by negative 1/3 is the same as multiplying by its reciprocal, namely negative 3. All right, and now that we've extrapolated this pattern backwards into the negative exponents for these remaining two tables, why don't you pause the video and fill them out and see if you can find any patterns. All right, so now that we're equipped with these three tables, let's see if we can generalize. Now note, we only did these for 3 specific numbers, but the patterns we find here are going to be true no matter what the base is. So let's talk about raising a number to the first power. Well, we found that 2 to the first power was 2, 2/3 to the first power was 2/3, and negative 1/3 to the first power was negative 1/3. And in general, any number raised to the first power is just itself. All right, now let's see what happens when we raise these guys to the 0 power. Well, 2 to the 0 power was 1, 2/3 to the 0 power was 1, and negative 1/3 to the 0 power was 1. And in general, that's going to be the case. Any non-zero number raised to the 0th power will be 1. Note, 0 to the 0 power is actually undefined. But for any number that's not 0, if you raise it to the 0 power, we're going to get 1. Now what happens when you raise to the negative first power, negative second power, negative third power? Let's start by looking at the 2 table. It appears that whenever we raise 2 to a negative power, we get the same thing as its reciprocal 1/2 raised to the positive power. For instance, 2 to the negative third power, we got the same thing as 1/2 to the positive third power. What about the 2/3 table? Again, it appears that raising 2/3 to a negative power yields the same thing as raising its reciprocal 3/2 to the positive power. For instance, 2/3 to the negative fourth power seems to be the same thing as 3/2 to the positive fourth power. All right, what about the negative 1/3 table? Again, it appears that raising negative 1/3 to a negative power yields the same result as raising its reciprocal, negative 3, to the positive power. For instance, negative 1/3 to the negative second power yields the same thing as negative 3 to the positive second power. And in general, this is going to be the case. Whenever we raise a number to a negative power, it's the same thing as raising that number's reciprocal to the positive power. For instance, if we're dealing with fractions, if we have the fraction a over b and we raise that to a negative power, we're going to get the same thing as its reciprocal b over a raised to the positive power. Or, if you're working with an integer, if you were to raise an integer x to the negative power, that's of course the same thing as raising the reciprocal of x to the positive power. And that's the exact same thing as just 1 over whatever x is raised to the positive power. So this is really helpful when you're working with integers, and this one's really helpful when you're working with fractions. And I'll say, being able to go very quickly from this to this will be very important in the very near future. All right, now just time for some practice problems. So why don't you pause the video and please evaluate all of these exponential expressions, and when you're done, play the video and we'll see how it went. All right, so I hope that went well for you. And just one common misconception that I want to clear up right now is that note, raising a number to a negative exponent doesn't mean that you're going to get a negative product. Raising a number to a negative exponent just means raise that base's reciprocal to the positive exponent. All right, guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.